Okay, learners, in our previous lesson, we did trigonometric equations, right? Those were very simple and basic. So in today's lesson, I wanna teach trigonometric ratios. Trigonometric ratios of the special angles Okay, trigonometric ratios of what? Of the special angles. So this will be our topic, but then before we learn that, guys, let me just project full screen. Okay, before we learn that, I want to talk about special angles. Okay, so what are your special angles that you must learn? Okay, so I want you to learn what are the special angles. What is the first one? Can you just say any that you remember? 30 degrees, it is a special angle, right? 60, but then before 60 we have 45 degrees. Then we can have your 60 degrees. Yes, bring them coming.
90 270
270
360
and 360. Why did we jump 180? 180 degrees, 270 degrees, and 360 degrees. Okay, these are the special angles that we are going to focus on. Okay, so once you know how to do these special angles, you will understand why at university, at tertiary, mostly those who do calculus in University of Pretoria, you are not allowed to use the calculator. Okay, so you just do math without calculator. And then once you understand this, you will get a glimpse of it. How do they survive? Okay, because of most of the questions they ask you are about angles which you can work them out without the use of calculator. Okay, so you have these special triangles that you need to memorize and know them. Once you memorize these triangles, you will be not intimidated. You won't be intimidated about special angles. So this is your 90 degrees, and then here it is 45 degrees, 45 degrees. Okay, then you have one here, you have one here, and you have the square root of 2, like that. Okay, then this is very easy. Having this triangle, you can answer multiple questions, right? You can answer sine 45 degrees without even having the calculator. You can also answer cosine of 45 degrees without having a calculator. You can answer tangent of 45 degrees without having a calculator. Because of once you say sine of 45, it means that sine, it is defined as what? Opposite over hypotenuse, right? Opposite over hypotenuse. And then in this case, let's say that you are here at 45. What is your opposite when you are here? Your opposite, it is 1. And then what is your hypotenuse? Remember your hypotenuse, it is always pointed by this. So your hypotenuse is going to be root 2. Then you know what is the answer for sine 45. Same thing applied to cosine, right? Cosine, it is defined as what? As adjacent over hypotenuse, right? So if you are sitting here, what is your adjacent? Adjacent, it is the side, which is 1, over hypotenuse, which is what? Root 2. By now, you should be able to notice that sine 45 and cosine 45 have the same answer. Okay? What is the reason for that? I'm really sorry about that. The reason for that, it is because of they are co-ratios. Okay? So, co-ratios, what are the co-ratios? Are the trigonometric ratios, sine and cosine, if you have the different degrees, they're gonna, if you have the different degrees on each of these trigonometric ratios, it only applies to sine and cosine. Those are the only co-ratios. So if you have 2 degrees that add up to 90, then they will give you the answer, the same answer. Like, let me just deviate a bit from here. We'll come back. Like if I say sine 30 degrees and cosine 60 degrees, right? 30 and 60, they add up to 90. So meaning that the answer that you will get here, it is the same answer as that you will get there. Okay? So that's why even there, 45 and 45, they gave you the same answer. Even if you can say 20 and 70. You are 20 and 70, they give you the same answer. So, I mean, 20 and 70, they add up to 90. They are complementary. So, they will give you the same answer there. I hope you understand the concept of co-ratios. Okay? So, tan 45, how do you define tangent? It is opposite over adjacent. So, tan 45 will just be 1. Because of 1 divided by 1, it is what? 1. So you see with this triangle, once you memorize it, you can do most of the things. Okay, then let's go to another triangle which is important. You must know these triangles. You must know them. They should be your friends. We call them special triangles, okay? So this is your 90 here. So this one looks like this. Let's say that it's 60 degrees here. And there is what? 30 degrees. Okay? Then this side you will have root 3. And then here you will have 2 on your hypotenuse. And then there you will have what? You will have 1. Okay? So from this one, we can also do a lot. We can give them sine 30 degrees, the answer of sine 30 degrees, right? We can give them the cosine of 30 degrees. We can give them tangent of 30 degrees.
Sine of 60 degrees.
Yes, we can also give them the answer to sine of 60 degrees. And cosine of what?
60 degrees.
Tangent. Of 30. Of 60. 60 degrees. Okay. So once you say that sine of 30 degrees, meaning you are sitting here, right? Then if you are sitting here, what is your opposite side? It's 1. And then your hypotenuse is what? 2. So sine 30 it is the same as 1 over 2. Cosine 30, you are still sitting here. What is your adjacent? Your adjacent is this side, right? Which is root 3. And then what will be your hypotenuse? 2. Okay. Then tangent of 30. Tangent of 30 will be what? Tangent, it is opposite over adjacent, right? What is your opposite? Your opposite, it is 1. And what is your adjacent? Your adjacent, it is root 3. Isn't it interesting? It's very interesting. Okay. So now we have sine 60 degrees. Okay. If you are sitting here, what will be your sine? It is opposite over hypotenuse, right? Root 3 over 2. It is equals to cosine now. Oh, Jesus. I forgot to give you the other side there, which is 1, right? 1 here, ne? So with cosine of 60, it is how much? It is adjacent, or cosine it is adjacent over hypotenuse, so 1 over 2, ne? Right?
Yes.
Let's continue. And also, you can have
Over
tangent
adjacent.
of 60. It is what?
Opposite over adjacent.
Opposite over what?
Adjacent.
Over adjacent, which is root 3. Okay, so this is how you can memorize your special triangles so that they can help you out to answer what? To answer your special questions related to special angles. Okay, so I have another method which you can use to memorize the special angles. Okay, let's try this method. So the method that I'm having now, you can simply say that you have sine x, and then down there you have cosine x, right? So okay, let me do this. Sine x, right? And then here let me just put cosine x. I'm sorry about that. So, and then let's say that let's say that he ish. Okay, I'm sorry about that. Sine x, cosine x. Let's say that there at the top you have your degrees, your special angles, right? Can we just name those special angles again? It's what? It's let's start with 0 just for the sake of starting from the scratch. 0,
30 degrees.
30 degrees,
45 degrees.
45 degrees,
60.
60 degrees,
90.
90 degrees. Let's stop here.
1.
Okay, then what do you do from there? You just say all of these things like this. You just divide throughout by you just divide throughout by 2. You just say this 2 divided by 2 divided by 2 divided by 2 divided by 2, right? The same thing here, divided by 2 divided by 2 divided by 2 divided by 2 divided by 2, right? After you do that, then you start here. You say 0, 1, 2, 3, 4, right? From there, you start here. You go there 0, 1, 2, 3, 4, right? Then you put the square root on each of them. Square root, 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 and square root. And that's it. Okay, so you can get your special angles by using this method here. Okay. So, and then of course, I know that we've got bigger angles, right? Bigger angles like what? Bigger angles like 180, 270, and 360. Those bigger angles, guys, you are going to memorize them by knowing your parent functions. Okay, let's draw a parent function of a sine quickly here. A sine looks like this. You must know it. So this is 1 there, and this is what? This is -1, right? And then a sine curve goes like that, right? So here it is 0. There it is 90 degrees, 180, 270, and 360. Okay, so all the answers that you need to know about sine and bigger special angles, you are just going to check here. If it's sine 90, you just go like this. And then what is your answer? Sine 90 is equals to how much? Sine, you go top and then you go there, it's 1. Right? And then sine 180, it's here. What is sine 180?
Equals to 1.
180 degrees is
Is
here.
equals to 0.
0. They say it's 0. Is it 0 or it's 0? And then here, you go for sine 270 degrees. 270 is here. You just do this and then you go there. What is sine 270?
-1.
-1. And then lastly, you go sine 360 degrees. What is the answer there?
0.
0. Okay? So this is a sine with bigger angles, right? And then how would you deal with cosine and bigger angles? You must know the parent function of what? Of a cosine graph. Let's draw it quickly. So cosine looks like this. Sorry about that. So this is how cosine look like. So you have 1 there, you have -1, right? And then let's do this. You have 90 degrees. After 90 is what? 180. After 180?
270.
After 270?
360.
360 degrees. Then your cosine function will look like this. We'll move from there to here, and then from here and this one. You see? And then from here and this one there. And then 360 and 1 there. Okay, so this is the parent of your cosine function. So meaning that if they say cosine 0, cosine 0 degrees, it is equals to how much? 0 is here.
It's to 1.
1. Right? And 7 and 90, cosine 90 is how much?
0.
0. And then cosine 180 is this one here.
-1.
Cosine 180 degrees, it is -1. And then what about cosine 270?
0.
Cosine 270 degrees, it is 0. And cosine 360?
1.
1. Okay? So we are left with the tangent 1. Ne? The special angles for what? For tangents. Let's draw a tangent function. So a tangent function, it is the one that has asymptotes, right? What are asymptotes? It has asymptotes. We'll just get it now. So when you draw a cosine function, this is your 1, this is your -1, right? Then cosine function, it's not the same. Oh, this is my y, this is my x. Their intervals are not the same as the sine and cosine intervals. Remember the sine and cosine intervals, they had a difference of 90 in between, right? It is because of the period. I will explain when I teach you guys how to draw the graphs. Okay, it is because of what? Because of the period. So how do you get this interval, guys? You just take your period, which is 360 for cosine and sine. Their periods are the same. All of them, they have a period of what? Of 360. Then you divide into 4. 360 divided by 4 is how much? It's 90 degrees. So that's why we were moving 90 plus 90, which is 180, plus 90, which is 270, plus 90, which is 360. For both of them, sine and cosine, their period is what? 360. Period 360 for both of what? Sine and cosine. Now let us talk about tangent. Okay, the period of tangent, it is 180 degrees. Then how do you get the intervals? You say the period divided by what? By 4, which is how much? 45 degrees. So that is why with the period, with the intervals of tangents, we will have 45, 90, 180, 135, and then
270.
Huh? Kuketso, she's leading me to mistakes. 45, 90. 90 plus 45 is how much? 135. 135 plus 45 is how much? 180. Okay? And so on and so on. But then let me just give let's continue. 180 plus 45 is how much? 225. 225 plus 45?
270.
270. 270 plus 45?
3 in 270 plus 45. 315.
315. 315 plus 45? 360 degrees. Okay? So now, with tangent, guys, tangent, you draw it like this. At 90, at the intervals of sine and cosine, we have I think your asymptotes are at 90, and then after 90 they are at what? I think at 270. We'll check that. Okay, so it's like this.
1.
So at 45 and 1 goes together like that, and it goes like that. You see? And then 135 and minus 1 go together, and then this will look like that. Okay? Then again at 225 and 1 we have a point, and then at 270 we have another asymptote. Okay, asymptote, that's when you press it, the calculator gives you error. Okay, or undefined. So, and then at 360, you have this. Okay, and then here it goes like that. So this is a tangent graph, which is very beautiful. Okay, so now we can give them answers. Okay, so let's give them answers. Tangent of 45 degrees. Remember, this one we can get the answer using what? Using our special triangles, ne? But let them just give them an answer. What is the answer for tangent of 45? 45, I'm here. 1. Right? What about tangent 90 degrees? It's here. Undefined, ne? Or error. Right? And then what about 135? 135 is here.
-1.
Yes. Tan 135 degrees, it is -1. Ne? What about 180?
1.
Huh?
0.
0. And then what about 225?
1.
Tan 225 degrees, it is equals to 1. Right? What about tan 270?
Undefined.
Undefined. Okay? What about 315? Tan 315? Even though it's not a special angle. Negative?
1.
1. And then finally tan 360? 0. Then those are your special angles. Okay? So how do you get your special angles, guys? From high school perspective, guys, I advise you to use your graphs, know your parents' trigonometric functions, right? Know your sine, how to draw your sine, the basic one, this one, the blue one, and know how to draw your cosine, the yellow one. Also know how to draw what? The tangent, which is turquoise. I don't know which color is this, guys. I did not go to multiracial. We only had 12 colors. and this one, it's one of those we did not have. Okay, so the beige, burgundy, and whatever, those are the colors that we did not do. And military or whatever, what do you call it? One of my favorite colors, it is, what do they call it? What's this color? Emerald. Okay, emerald green. It's one of my favorite color, especially on clothes. So those are the colors that we do not have in the school that I went to. Okay, so for you guys in matric, not in matric, in high school, learn your special angles. Use these two triangles. Know this triangle, the red one. Know the neon one. Is it neon or green or lime green, whatever it is? Know this one, and from there know your three graphs, right? Your sine basic graph, your cosine basic graph, and finally your tangent basic graph. Then you will know how to answer your special angles. Once they say that tangent 180 degrees, if you have drawn this so many times, you won't even need to redraw it. You will just close your eyes and imagine it. How does it look like? Then you say, but then tangent at 180, it is where it is on top of the x-axis. Then you just say it's 0. And now they say tangent 90 degrees. You say at 90, that's where we have asymptote. So it is undefined. When they say tangent of 45, you imagine it, you just close your eyes and you imagine it. Oh, at 45, that's where it is at 1. Okay, this is 45 and 1. When they say 225, you know that it's also at 1. 315, it is at -1. So you see, once you know these ones, then you do not need calculator to answer them. So most of the questions where they want you to, or where they give you the special angles, they will always tell you that without using calculator, because of they know that special angles do what? Will help you out. Guys, I try to keep these lessons as short as I can, but then it seems like this one has overlapped a lot. There's still a lot that I want to say about this, but then for now, guys, just allow me to end this lesson. Okay, thank you, guys.